Okay, so we're going to find the standard deviation. Oh, I know it's a little, step one is probably, the first thing here I have is probably redundant because you have to find the mean anyway when it comes to finding the standard deviation. Now, as you can see, what we do again is we add up these results and we divide by how many numbers there are, how many data values there are, right? We add them, as you can see. In doing so, we get 60. 60 over 12 is 5. So the mean is 5. Okay. Now, not only that, okay, what we do next, remember, is we can list the data values. Now, we can list including repetition as well. We do that. I mean, the next example we'll actually do one that has that involves a frequency table. But here we're listing the data values. And now what do we do next? We subtract the mean. Data value, subtract the mean, and square the difference. And then square. And we get 3 squared is 9. The first one. Here, right? Subtract the mean, square it. Same thing here. Same thing here. And so on. We have all these squares here, okay? As you can see. Now we're going to add them up. If you add all these up, you end up getting 58. I probably would use a calculator because that's what I used actually was Microsoft Excel to add these up. So that's okay. And remember, this is a sample, right? I don't know if I said it, although as I said before, if I don't tell you if it's a sample or population, then we can assume it's a sample. We can assume that. So we divide by 12 minus 1, which is 11. Doing so, we get 5.27. Now for the standard deviation, right? Remember, what we do is we take the square root. Just like before. I know I didn't write it in, but I'm writing it in now. And if you do that, you get about 2.30. .30. Okay? There we go. So again, we take square roots, right? And that's how we get the standard deviation. The number we have right before we take the square root, or if you can think of it this way, what we're taking the square root of, that's the variance. This is our standard deviation. All right. Any questions on this? Okay, so let's do another one then, okay? Let me just see some, okay, good. I didn't know if I had the mic on, so. Okay, so this one's a little bit different. Mostly because, as you can see, I'm giving you a frequency table. I mean, yeah, it's, this problem actually came from the book, okay? I guess you could imagine asking 25 randomly selected students how many movies they watched last week on Netflix or Hulu or whatever, although here it's Netflix. And this is the frequency table we got. I know what you're thinking. You could probably just list the data. In fact, I did that here. But what I'm going to do instead is just work directly with the frequency table. Okay? I'm going to do that instead. Okay? That's what we're doing. All right, that's cool. So now, what do we do next? Let's get the mean. Now, it's just like before. What you want to do, we've done this before, you take each data value, you multiply it by the frequency. You add up the products, right? Again, if you were to list this data out, you would have 0 listed 5 times. 1 would be listed 9 times. 2 would be listed 6 times, and so on. For the mean, you would add up all these data values. Like so. Okay, so again, that's the same as doing the number times the frequency and adding up these products. And you want to divide by the number of data values, which is the sum of the frequencies. So doing that, we get 37 over 25, which is 1.48. Yeah. So that's what we get. All right. So next, what we do here, this one's a little bit different. It's almost like as you can see, I'm listing the data values. I'm not allowing repetition, so to say. I'm keeping each data value with its frequency. Okay, I mean, I would imagine this is a lot easier, and you would rather do this than have 25 rows, listed. But again, with each data value, keep the frequency. So for 0, right, we have the frequency 5. We're going to take the data, subtract the mean, right? The mean we just calculated down here. We get this. Then we square the result, like so. And you can imagine this would be listed 5 times if we listed every single data value. Here, for 1, right? You can imagine this listed 9 times. This is its frequency. So we subtract the mean. Okay? Square that difference. We get this. We get this, as you can see. Okay, so that's good. Next, right, and again, this is 9 times. So if I were to list the table, if I were to list every data value, you would be doing this 9 times. You would have this difference squared 9 times. And you keep on doing this for 2, 3, and 4. Now, you want to add up the results. Well, excuse me, got ahead of myself. You want to multiply each number by the frequency, okay? Because again, you can imagine we're doing this for 5 times because 0 is listed 5 times. We're doing this 9 times because 1 is listed 9 times. We're doing this calculation each time we have 1. Here we're doing this 6 times each time 2 is listed. So we're multiplying, we're adding up these results, but we multiply each number by its frequency. Okay? Each one by its frequency, as you can see. And again, we're dividing by 25 minus 1. But 25, again, is how many data values there are. But it's sample data, right? So what we're doing is we divide by 25 minus 1, which is 24. So altogether, we get this. And the standard deviation is the square root of that. I mean, this one I wanted to do, it's a little bit different because you have the frequencies here. The idea is the same though, the underlying idea. It's like what we did with the mean, right? Each number you multiply by its frequency when calculating the mean. Same idea. Are there any questions about this? Okay, let's move on now. So here we have a sort of another measure of variability. Instead of using standard deviation, we can use what are called quartiles. And I checked and I looked up the word actually, quartiles. I am pronouncing it correctly. I was concerned I wasn't, but I am pronouncing it correctly. Quartiles are used to break up the data into quarters. Namely, you have these numbers, Q1, Q2. Q2 is actually the median, Q3. And these three numbers are used to break up the data into quarters. Namely, with Q1, 25% of the data is below it. Q2 is the median, and we actually have seen this already. The median is so that 50% of the data is below it, and 50% is above it. Q3, 75% of the data is below it, the third quartile. We also have the min and max. Well, sorry, that comes later. But the quartiles are used to break up the data into quarters. So for instance, 25% of the data is below Q1. The next 25% is between Q1 and Q2. The next 25% is between Q2 and Q3. And 25%, and the remaining 25% is above Q3 and less than the maximum. And in fact, we get this so-called 5-number summary, which is the minimum, Q1, the median, which is Q2, Q3, and the maximum. Sort of a 5-number summary, as they call it. Okay, that's great. I mean, how do you calculate these? Well, the min and max is actually, that's pretty easy. What we do first, of course, let n be the number of data values. We're going to sort the data from smallest to largest. If there's a lot of data values, you could use Microsoft Excel to sort it if you want. You don't have to, or you can use Google Sheets. I think I've showed you how to do that when we were dealing with, histograms, I think, if I remember correctly. What you do next is this.